Welcome to Section 6A. This is where we're going to be characterizing data. The first one is average or mean. Most of you have already been familiar with this for a while. This is when you add up all the numbers and divide by how many numbers there are. The median is the very middle number, but sometimes if you have an even number of numbers, you pick the two middle numbers and then average them. And this is very important. Make sure that you're writing all of your information from low to high. Very frequently I'll have somebody find the middle number, but it's not really the middle number because it's been all rearranged. And one way that I like to remember that median is the middle number is that it has this D right in the middle, and it's like the D's in the middle of the middle. And that's how I like to remember that. Mode is the most common number, or the one with the highest frequency, and you can have none, or you can have two of the same numbers, or three, that have the same frequency, the largest. Let's go with our first example. Find the mean, the median, and the mode of this price data. Excel is really convenient. Now, these are actually listed from low to high, but I reorganize them because frequently they're going to be not from low to high. So I've already typed it into Microsoft Excel. I'm going to come over here and say I want to sort this from smallest to largest. And that was really fast. Very convenient because when I'm looking for the median, which is the middle number, it has to be from low to high. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. In this case, I don't have an exact middle number. I have two. These two numbers are the middle. So for the median, I need to average these. The first thing, we should have found the mean or the average. In this case, I can type in sum, add all of these together, close my parenthesis, and then divide by 8 because there's 8 data points. And that's my average. Another way of doing this would be typing equals and type in the word average. And I'm not going to get that last number because that was how I calculated the average previously. And those two match, so I did it right. Now let's go ahead and find that median. I want to find the average between these two numbers. So I'm going to put in parentheses because I need to add these before I divide by 2. Add, divide by 2, or I could have also done equals average and average these two numbers. There we go, 1.37. The average of the whole thing is 1.41. The median is 1.37, and the mode is the most frequent. Mode and most also sound similar. So which of these? It looks like 1.29 is the only one that has any sort of repetition, so it has the most frequent. All right, let's go back in. 1.41 for the mean, we already have that. 1.37 was our middle number, and the mode 1.29 showed up the most frequent. Let's move on to B, the effects of outliers. An outlier is a number that is much higher or much lower than most of the numbers. In this case, I have 0, 0, 0, 0, and then $3,500,000. So if I wanted to find the mean, I would add all of these and divide by 1, 2, 3, 4, 5, which gives me 700,000. The median, however, is the middle number, and that's 0. The mode, also I have 4 zeros, so the mode is 0. Notice that outlier made the mean much, much bigger than the rest of the numbers. That's why it's called the outlier. It doesn't really match, and it is affected. It's either pulled up higher or lower. If I had a very low outlier, in this case mine is high, it affects the mean. The median, not affected as much by the outlier because it's right there in the middle. Mode, also not affected by the outlier. I take the most frequent. This one, definitely affected by the outlier. Let's move on to our next example, C. Here are some heart rates, 130, 135, 140, 145, and 325. Which of these should I use, the mean, median, or mode, to characterize my data here? Well, if I did my mean, this 325, by the way, is totally ridiculous and probably a mistake in the figuring out of the, I'm guessing a mechanical error or electronic error. So I wouldn't use the mean to characterize the middle of this data. I would probably use the median because there's not a mode here, so I would just go to the middle number of 140. Example D. There was a confusion about the average wage dispute. A company reported that the average wages were $22 an hour. The workers stated that the average was $19 an hour, but management was stating that the average was $23 an hour. So how can that be? Well, if we take some data points like 19, 19, 19, 19, and 39, and I find the mean, averaging all of these together gives me 23, and that's what the management was claiming was $23 an hour. But the workers were claiming $19 an hour. They were also claiming the mode, but they were both right in the end. Let's move to the next one. I have 100 students that are taking 3 core classes. The first 2 courses are very large lecture halls with 100 students in each class. The third class is 10 classes of 10 students each. The students are claiming that the average class size is 70 students per class, but the administration is claiming that the average size is 25 students per class. So let's look at it and see if they're both right or if somebody's lying. So the students are looking at their own schedule. They have 3 classes. Their first class has 100 students, 100 students, and then 10 students. Divided by 3 gives them an average of 70 students per class. The administration is looking at the overall students per classes. There are 2 lecture halls and then 10 smaller classes. So there's a total of 12 classes and 100 students at each of those time periods. So they have 100 for the first lecture hall, 100 for the second lecture hall, and 100 for the 10 smaller classes. And there are 12 classrooms altogether, which makes it 25 students per class. They're both correct, and there's different ways to manipulate the numbers, and you need to be aware that sometimes people are trying to use their averages or the mean to favor what they want it to favor. Number 2, shapes of distribution. A histogram or a line chart can be connected with a smooth curve to approximate the distribution. So here's my first histogram, and we just kind of approximate by making it a nice smooth line. This is different than what we did previously, which was stating that the histogram and the line chart are the same. This is finding the shape of what the information is giving us. There's different ways to characterize this. There's 1 peak, which is unimodal, 2 peaks is bimodal, and 2 or more peaks, or no peaks at all, is a uniform distribution. A lot of students get confused if they see any variation, such as this one, and it jumps up a little bit. They think it's bimodal. Like this one, I have a peak here and it goes up. We should expect some variation. It should go up and down a little bit between these. So make sure that I think I might even go as far as to say that this one might be bimodal. But this one is definitely not bimodal because even though I have this one high one, it might just be some outliers. So the whole shape of it. let's go down here. This is a normal distribution. This one I would definitely say is bimodal. I have a very distinct two peaks. This is uniform, where there's no peaks. Or, in this case, I have many different, and it really doesn't create a curve, so again, I would also say uniform distribution. We have some examples that I'd like to talk about, and we're going to think. Now don't look at the answer, so maybe use your right hand to cover up the screen. We're going to think in our mind, what kind of distribution would it be without actually going through and finding the histogram? Our first one is heights of women in college. Now we're using college women versus younger children because we've already reached the height for the average Americans. So heights of women in college. So close your eyes and think about women in college. We will have most of them about the average height. Now you will always have those who are higher and lower, or taller and shorter, but I don't see two peaks, so I would say unimodal. Now if I say the heights of students in college, so that means all students, that gives us male and female. Well, I know women have an average height that is shorter than men, and as we talked earlier with our histogram, the histogram was bin to data, and down here is an axis going from a low number to a high number. And because women are averaging at a smaller number or a smaller height than men would average, then I would say that the women would peak and then the men would peak. Now granted, I will have some women that are taller, but not very many, so it peaks and then the frequency decreases. Remember, these histograms are frequency charts. So the frequency would decrease before the men's frequency picks up at a much higher or taller height. And of course I will have this area here where I will have some shorter men, and I will also have this area here with some shorter women. I guess I should have used this example. So women peak, and then down here I'm going to have some taller women or some shorter men, and here I'm going to have most of the heights of the men at a higher range than the women. Again, remember, down here is the axis from low to high, and this is binned data, so I'm going from, let's say, 50 inches to 55 inches, or 54 inches, 55 inches to 59 inches, and then 60 to 64 inches, and so on and so forth. And the women will definitely peak at one place, and the men will peak at the other. Remember, the height over here is the frequency. So I am going to say bimodal. Men will peak at one point, and women will peak at the other. Now the last example is the number of people with particular last digits from 0 to 9 in their social security number. Because I don't see any sort of bias towards ending in 0, 1, 2, 3, all the way up to 9, I'm going to say this is pretty uniform. And it might have some variation, or it might actually be pretty uniform right straight across the top. Now let's talk about the other defining characteristic of data, which is the symmetry. Symmetry is like looking in a mirror with two mirror images or halves. So in this case, I could cut it straight down the middle, and it's a mirror image on both sides. Again, here, cut it straight down the middle, and it looks the same on both sides. If it is not a mirror image, it's considered to be skewed or not symmetric. I have the option of being left skewed or right skewed. Left skewed means I'm spreading a little to the left. I have a few outliers, and remember, it's going from low to high, so these outliers are down in the lower region, and it kind of looks like it's being pulled like a rubber band or Play-Doh on the left side. So that's left skewed. Right skewed means that the outliers and everything is spreading to the right. It's like it's being pulled on the right side by these outliers on the right, like a rubber band or some Play-Doh or a silly putty that's being stretched out that direction, and that's the right skewed, being pulled up by higher outliers. On the symmetry, if the mean, median, and mode equal each other, then it's beautifully symmetric. If it's being skewed this way, remember the outliers are over here, that will bring my mean down because the mean is affected by outliers. If I have some outliers that are up high, like we did in our previous example, the mean's being pulled to the higher end. Some examples. If I take the height of a sample of 100 women, well, we already talked a bit about that. It's going to be unimodal and pretty symmetric. I'm going to have a couple of lower heights and a couple of taller, and it's going to end up balancing out nice and even. If I look at family income in the US, most people will be right at the medium and lower income levels, but there are going to be a couple of very high numbers, a couple of million and billionaires that are pulling way out to the right. Remember, I'm going from low to high, from left to right. So yes, again, we're going to have some who are very low, but most people are the middle class. And then of course I'm going to have some outliers way up to the right pulling. So I would say all of the income in the US would be skewed to the right. Now let's talk about the speed of cars on a road where there's a visible patrol car. Most of the cars will be right at that speed limit, but there are always those few cars who will be overly cautious and driving very slow under the speed limit. Now most of them will not be over the speed limit, right? And we're going from low to high, so most of them will be right here at the middle, but a couple of overly cautious people will slow way down. And remember, the lower numbers are on the left, so that are considered to be skewed to the left. Now let's talk about variation. This is about the variety of my data down here. So the variety, if I have a much skinnier mode or peak, that means that my data is only being held from here, this number to this number. That's a very small or narrow range. But if I have a very wide peak, then my data is spread over a much greater range, and therefore I have a much wider variety versus this very narrow one where my variety is only from here to here. So the variation is very small. So if I talk about Olympic marathon times, am I going to have a low variety or a high? A low variation or a high variation? Well, think about Olympic marathon times. I know that their timer goes way out, not just to seconds, not even to a tenth of a second or a hundredth of a second. I believe they go out to a thousands or even the 10,000ths of a second, fractions of seconds to see who was faster. These variations are going to be extremely close together, so the low variation would be more appropriate. Now let's compare that to the New York Marathon. The New York Marathon has lots of untrained or just athletes of all shapes and sizes, which means I'm going to have a much bigger variety of people coming in over the finish line. In fact, people, if you've seen it on the news or recordings, you'll see people coming in at different hours even. And so I have a much higher variation versus the Olympic marathon times. All right, that's the end of section 6A. I hope you join me on the next section of 6B. Good luck on your homework.